The following is a model of pitch displacement autopilot with rate feedback. So here we have our rate, and we go back to position by multiplying by 1 over s, which is the Laplace transform. And it comes from the idea that when we have a derivative of a function in terms of t and we take the Laplace of it, what this is s times big X of s minus the initial condition. And the pattern follows if we have a second derivative, third derivative, and so on. So if you assume that we're trimmed, then our initial condition is 0. And we usually assume that for these models. So now we notice that the derivative of the Laplace is s multiplied by this. And we know that the function without the derivative was just big X of t. So if we divide by 1 over s, we get back to the function for the position. And that's why we have 1 over s over there. Determine the closed loop transfer function for a q over q ref. Q over q ref. I'm not sure what this means. Note you will have to determine the closed loop transfer function for the inner loop first. So the inner loop is this guy over here. That's the inner loop. K-amp and KRG, which are over here, represent the gain of the amplifier and the rate gyro, respectively. Okay, so to collapse this into just a forward path function, we use the magic formula. So collapsing, and this is 8.3, collapsing the inner loop. So we use G over 1 plus G times H. And we'll call this inner. So how are we going to do this? Well, you have to remember, what is your G? It's everything in the forward path. So that's 10 over s plus 10 and the other box over here. They're both G. So let's write that as 10 over s plus 10 all multiplied by 1.39 times s plus 0.3306, all of it divided by s squared plus 0.805 s plus 1.325. Okay, and we close this. That's going to be our G. Now our H is going to be everything in the feedback path. And that's the path that's going to the left. So the one that has KRG. And there's only KRG, so that's basically all we're going to have for H. And then we're going to have to rewrite G as well. So let me take this, just to save some time. We're going to copy, insert, draw text mode. Here, we're going to paste it. And let me get rid of that. And now we have this. Close the parenthesis here. But we want to add our K, RG. Okay. So that's what we have for the inner loop. Now we want to find the outer loop. And to find the outer loop, what we want to do is we want to do the same process. But now the outer loop, so the outer is going to be everything in the forward path, which is going to be, well, the first thing that you encounter is K-amp. So that's part of G, because we're using the same formula. It's still going to be g over 1 plus gh. But now our g is everything in the forward path of the outer loop. So it's going to have k amp and the g for the inner. So the inner, what we called inner, and at the bottom is going to have 1 plus g is going to be whatever we have at the top, so k amp inner. And now we're going to have times h. And h is this what we have. Oh, and also we forgot 1 over s here. H is what we have in the path going back, which is just 1 because we don't have anything. And remember, you can't put 0 because if you put 0, you don't have a feedback loop. So that would be kind of like having a k of 0. So you don't want to do that. When you don't see anything, put a 1. And that's going to be your overall system. And then you would do the math and everyone would be happier. But I'm just going to leave it in general terms because this is very nasty. I need MATLAB to not make a mistake on that one. I mean, not really, but yeah. So that's how you would do it. I'll see you next time.